Voltage regulation. What is voltage regulation? If I have a 9-volt battery and I want to power up a 5-volt fan, how can I do that? Is it possible to connect the 9-volt directly to the 5-volt? The answer is obviously no, because the fan may be damaged. So I need to convert the 9 volts into a constant 5 volts so that I can power up the 5-volt fan. So the process of converting a 9-volt to a constant 5-volt is called voltage regulation, and the devices that used to convert the voltage is called the regulator. In e-device, the voltage regulator that we will be looking at is implemented using the Zener diode. Zener diode as a voltage regulator is always in this form. It has a series resistor, and together with it connected in the reverse connection, and the Zener diode is actually connected in parallel to the load resistor. Okay, and basically referencing to the earlier example, the Vs is actually the 9-volt battery and the RL is a 5-volt fan. So the Zener diode, acting as a voltage regulator, will convert the higher voltage Vs to a constant Vz value to be connected to the load. Do take note that in order for the Zener diode to work properly, that means maintaining voltage regulation, it always operate in the reverse breakdown region. In order for the Zener diode to maintain regulation, the condition is to make sure that the current flowing through the Zener diode Iz must be between the minimum value Izk and the maximum value Izm. The other condition is to make sure that the voltage supply Vs is greater than the Zener voltage itself. When we analyze a Zener diode circuit as a voltage regulator, we always look at the KVI equation here, and from here we can see that the current IT is basically given as IT is equals to the voltage Vs minus the voltage Vz divided by the series resistor. So IT basically is Vs minus Vz over the resistor Rs. Since the Vz is parallel to the load resistor, the current flowing through the load resistor IL is basically given as Vz divided by RL. It's basically Ohm's law. If the diode is maintaining regulation, you can say that in this case the V out is equals to Vz. Alright, when we do a KCL at this node here, we can actually derive that the total current IT is equals to the Zener current plus the load current IL. In fact, all the circuit analysis for the Zener diode is actually based on these three equations. IT, IL, and the KCL equation.